Hi and welcome into another LEETCODE challenge. Today we'll be dealing with a convert sorted array to binary search tree, which is an easy one. Given an integer array nums, where the elements are stored in ascending order, convert it to a height balanced binary search tree. Height balance, what is it? A height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than 1. Let's see an example. So we are getting this nums array, which is here, like -10 to 9, and we are setting it to this particular tree. And here we have an example 2, which we get 1 and 3, and we get either 3, 1 or 1, 3. All right. Let's think about it for a moment and get back to the LeetCode console. Alright, so we are back in the LeetCode console. I will be using JavaScript, but you can use many other languages as well. So whenever we dealt with some kind of a binary tree, and we did already few of such problems that you can see in the playlist down below for the LeetCode on this channel, we were using some kind of a recursion, and today we will also use recursion. Let's see how this was done. So we got an input of nums, which is sorted array like this, and we see that the root of this tree is the middle element, and everything to the left was on the left side, and everything to the right was on the right side. So we will take such approach here. So firstly, we will do a call to our recursive function. Let's call it a recursive. And what we will pass? We will pass the nums array, which we need, and we will instantiate a left pointer and a right pointer. On the beginning, the left pointer will be 0, and the right pointer will be nums length -1. So the last element of the array. So here is our call of our recursive function, and then let's create this function. So we will do function recursive, and what we would like to pass? We will pass nums left and right. As it is a recursive function, we always need some kind of a base case so that we don't have a function that runs indefinitely. So what would be our base case right now? The base case would be set on the markers. So if the left marker will move through the right marker, so will be more than right, then we will stop, because we know that we used all of the elements. So let's code that. We will do left greater than right. We will just return null, because there is no more elements that we can add to this tree. What we want to do right now. So if this base case is set, the next thing we need to do, we need to always find the middle element. So let's instantiate a variable called, let's say, I, and in I we will do a left marker plus right marker, and we will divide it by 2. So in this particular example, we will take 0, because left is 0, and we will take right, which is currently 4, and we will, because there are 5 elements -1 to take into account 0 based, and we will divide it by 2 and get 2. So this will be our root. But we also need to account for the array, which will have a even number of elements. So let's say there would be yet another element here, and we would add 0 plus 5, we would get 5, divided by 2, it would give us a 2.5. So we will do a mat floor here on all of that. And this will give us the element in the middle. So now, right now, in each recursive call, we will create a new tree node. So we will do const root equals. Here we have already a declaration for that, val left right. So we will take new tree node. The value will be nums at I, because if the middle element was 0, this will be a root for this node. And for the left and right, on the beginning, we will add nulls and deal with that in another lines. So now we want to create this left node and right node of this root tree. So we would want to populate it in this particular example with this -3 and 9. So here will be our recursive calls. So we will do root at left will equal to one more call for the recursive. We will pass the nums array. We will pass the left as it was, and we will move the right marker. So we will do right -1 because we want to take everything on the left side, but we already used right as it is because it would be actually this I element. So we need to do it this way. We need to take I -1 because we need to take whatever is on the left from our middle element. And the same we will do for right. So we will do here recursive nums. Here we will pass I +1 because we want to take everything on the right from the middle element, and we will pass the right marker. So those are our recursive calls, and at the end let's just return the root and see if it works. So I will run it. We have both case accepted, and I will run the whole suite. Yeah, and we are accepted on that. So this is yet another binary tree problem that we solved using recursion. Hope that it helps and you learned something new. See ya next time.